Hello and welcome to the show where we do science, where Ryan Elementary students discuss all things science. My name is Professor Apex Legends and these are my two lab assistants.
Hi, I'm Layla. And I'm Emily.
Today's experiment is called Charge and Carry. It's all about magnetism.
As you can see, we have a styrofoam cup and a pie tin. And over here we have a styrofoam block and a cloth.
And fingers. First, we will begin by rubbing our cloth over the styrofoam block. This will negatively charge our surface. Next, we'll take our cup that we've taped to our pie tin and drop it onto the styrofoam block.
Safety first, kids.
Would you just please touch the pie tin?
Okay, I don't think I should.
Just do it. Now I will carry this charged pie tin and my other assistant will touch it. When you put the pan on the foam, the electrons on the foam run away from the electrons on the pie tin.
Since the electrons can't leave the pie pan because it is completely surrounded by insulating air and foam, the tin stays neutral.
If you touch the pie tin while it's near the foam plate, the mobile electrons will be pushed off the pan and onto you.
And that makes a spark that you can feel through your fingers. See you next time on the show where we do science.
Today we are studying matter. Most matter takes one of three forms: a solid, liquid, and a gas. These are the phases of matter.
Matter is a bunch of tiny little things called molecules. Imagine one kid in a line of kids. One kid will be a molecule while the other kids all together form the substance.
A solid is the most rigid form of matter. You could push it, break it, it stays together in some form. How do you change the form? The answer is heat.
Happy chocolate. To see if it changes. Changing color, changing shape, changing color. Rectangle, circle, square.
A circle that's like blobby.
A flat circle, you mean? A flat circle, you mean? Gooey, liquidy.
Gooey and liquidy?
Like
And
mushy,
like and kind of sticky. My hands are
I'm so sweaty.
This is what happens if we apply heat to this chocolate. It will change shape.
What will happen? Look, the shape changed.
After we apply heat to the solid, the structure changes.
It's still the same matter, but instead of being stuck together, their bond has broken down.
It has changed the solid into a liquid, and if we apply more heat, they lose their bonds together and they become gas.
Hi, my name is Marco Vega.
Hi, I'm Omar Garcia.
Hi, my name is Joanna, and we
We'll be demonstrating force, motion, and friction.
It's the opposite.
It's the opposite.
Review what we learned at the end.
Me.
Okay, we're just gonna say our names.
You're gonna do the review.
So force is a pusher tool. I'm gonna demonstrate the car going down the ramp, and I'm pushing it.
And I will demonstrate that this ramp has less friction that causes the car to go faster.
What's your favorite series? This one makes the car slower because it has more friction than this one.
Sir Isaac Newton's first law of motion is an object in motion will stay in motion until acted upon by another force.
Another force that stops the car's motion. Today we're going to review what we learned.
An object in motion stays in motion until acted upon by an outside force.
Friction slows an object's speed.
Last year's experiment proves that the carpet has more friction than the ramp.
Thanks for watching!
Okay. All right. So, what's up? Hey, can somebody hear me?
Let's make a circuit. We're going to talk about conductors and insulators. A conductor is something that can hold an electric current. An insulator cannot.
Let's make a
Hypothesis.
I think the paperclip is going to be a conductor.
I think the banana's going to explode.
This is science. Moving on.
Lab assistants. What did you bring?
I grabbed paper clips, a banana, and 2 wires.
What did you bring?
I got a soda can, 2 wires, a battery, and 2 light bulbs.
Let's
Make a circuit. I'll get this side.
And I'll get this side.
Okay, so can we have the light, please? Just kidding.
That's so amazing.
That's science.
Let's see if the DP can is a conductor.
Okay, so I will connect it to the DP. Okay. Now we're going to connect it to the light. Okay, 3, 2, 1. It's a conductor! Yay! Okay, let's see if this banana is going to explode or it's going to be a conductor.
Damn it. We're going to take this part, connect it to the end of the banana. And put this part, and
No,
it's an insulator.
It's an insulator. Aw, I wanted it to explode. This is our experiment. Thank you, UNT, for watching The Elaborate Scientist.
Cut.
Hi, my name is Aileen.
Evelyn.
And Yariana.
And I'm Brian.
I'll make it.
And we are the Science Kids.
Today we're going to be talking about landforms.
Let's get started.
Today we're gonna do a landform experiment.
What are landforms?
Landforms are mostly weathered down by water, wind, and ice. Most landforms are carved out by river flowing through it.
And that's called erosion. The materials we're gonna be using is
Water, sand,
Ruler, tape, scissors, and cups.
the first step is to pour water in the sand.
We need to pour water into the sand because the sand is dry and we need to create the landforms.
These are the landforms we did. We did a mountain, a plateau, a cave, a river, and that's all.
First, how landforms are formed is by erosion, by the water, wind, or ice goes and picks up materials and makes one and make the position, and then the weathering or breakdown of sediments and happens, and causing by that the cycle goes again and again.
The water that we just poured into our experiment affected the landforms by
The water damaged the landform because the sand started sliding down.
Thanks for joining the science, kids. We hope we see you next time. Thanks for joining us.
Bye.
Guys, it's recording. Hello.
Hello. Ava.
Oh, hi, I'm Professor Ava.
I'm Dr. Pepper.
I'm Dr. Ashton Connor,
Hello, I'm Autumn R.
and today we're telling you about refraction. Refraction is the bending of a wave when it enters a medium such as water, where its speed is different.
Einstein's theory of light says light moves at the same rate, but when light moves through different objects, it will look distorted.
God darn my legs. All right, we can keep going.
The refraction of light when it passes from a fast medium like air to a slow medium like water bends to the light ray.
Because the light can't travel as quickly in water as it does in the air, the light bends around the pencil, causing it to look bent in the water. Now it's time for the experiment! We are going to take this pencil and put it in the water.
As you can see,
The water
Refracted.
refracts the light to where it looks like the pencil is bent two different ways.
But it's not actually bent.
Yeah.
See?
Hello, today we'll be studying the reflection of light, like when they bounce off a mirror. Jaden will be demonstrating how light bounces off other objects.
The reflection of light bounces off like a ball.
Light bounces off a shiny or flat surface. As you can see, it's now on the table because it's bouncing off the mirror with the light, just like it bounces with a ball like Jaden showed us.
When light hits an object, such as this book box, the book box absorbs light, but only some of the light. The rest of the light comes back to us, to our eyes, as blue.
Have you ever went on top of your bed and made shadows? There's a shadow there because solids such as your hands absorb light and cast a shadow. Now that you know a little more about how light behaves, go see it for yourself. Thanks for watching!
Go subscribe! Subscribe!
hello.
Hello, and welcome
to the Faces of the Moon. Brought to you by His History Class. Also sponsored by UNT. Yeah.
Today we're going to be looking at the moon and its phases.
There's 8 phases of the moon. Those phases include new moon, waxing crescent,
First quarter.
Waxing gibbous, full moon,
waning gibbous,
last quarter,
Waxing crescent.
And the new moon again.
And now we shall be doing the experiment.
This is the new moon. We know this is the new moon because we can only see the half of the moon that is not in the ray of sun's light, so it is cast by the shadow. We cannot see the moon.
The next phase is the first quarter. We know that it's the first quarter because half of the moon is showing. The other half we can't see because it's not faced towards us, and the moon's light is facing towards the half that we can see.
The first quarter is only the quarter of the moon, which the light is on the right, and the darkness is on the left. This is the gibbous. It almost looks like a full moon.
This is the full moon. You think you see the full moon, except it's only half the moon. The other half is where you can't see it, so it's dark. The light from the moon is actually just the sun reflecting on the moon.
The last quarter looks like half the moon, but it is only a quarter of the moon.
So the waning crescent looks like a fat sea.
The next phase of the moon is the new moon.
The new moon looks like there is nothing in the sky. It also looks like the moon didn't want to show up.
The moon phases start all over again right after the new moon.
Joining us on our phases of the moon. Be sure to remember the phases of the moon and why the moon is very important to us.
Phases of the moon.
The moon likes to wax its jokes. Then he tells the jokes. But then the moon realizes that he has terrible jokes.
What's bright at night and reflects the sun's light? The moon.
Yeah, it is.
What's a cow's favorite dance? The moonwalk.
Who cheesier than me? The moon. The moon is bright at night and reflects the sun's light.
Ooh. And also, their joke is why is it called the waxing crescent? Because it's waxing the croissant. What does that mean?
Hi guys, welcome back to my YouTube channel.
For this phase of the
Yeah.